In this video, we're going to be addressing angles based on forms of symmetry. In this part, we're going to look at the first, which is known as the odd symmetry, while the other type of symmetry we're going to be looking at is, you guessed right, even symmetry. And these two symmetries will be applicable to not only which categories our trig ratios apply to, but most importantly how we can locate these forms of symmetry in their respective graphs. And so we're going to start off with our symmetry. We're going to look in details about the definition after we come up with our graphs. And yes, the first ratio, which is trig ratio, that is applicable to odd symmetry is known as the sine, and this sine trig ratio is known as the opposite divided by your hypotenuse. Now the other odds ratio that is applicable here is known as the tan ratio, and the tan ratio is expressed as your opposite divided by your adjacent. And finally, for the even, of course you figured it out, it is known as the cosine, and this cosine trig ratio is known as or determined by dividing your adjacent by your hypotenuse. And so we are able to now classify these based on which ones are odd and which ones here are even, in this case just cosine. Now you might be wondering, why did I put sine and tan under odd symmetry and why is cosine under even symmetry? This is coming from how they look like on a graph, and this graph here we're going to plot it for our sine and see how we can use the graph to define what odd symmetry are. Looking at the purple boxes, we see axes that are shown right here. The horizontal is labeled as your angle, in this case theta, and while your y-axis here is represented for our sine as sine of our theta. Now looking at our sine, which is our opposite of our hypotenuse, we see that the graph for this particular trig function or ratio specifically is in terms of, yes, our zero angle is going to be starting at 0 for our sine, and then we move up to the maximum, which is 90 degrees, moves back to 0, 180, and then to -1, which is 270 degrees. Now we can do the same thing as we move to the other side, and this here goes down to -90 as minimum, and then back to 180 as 0, and then to, in this part here, to -270, which is represented as our +1 value. Now what we see here for our sine is the following. On our particular center, which is the 0 region, we see that our origin is going to be showing a particular symmetry that is as follows. Looking at one part here, which is moving from 0 to, in this case, pi over 2, we recognize that the value of our sine of pi over 2 is equal to 1. And what we see is that if we move the other way to the other side and we check for -pi over 2 as our angle, our result for sine is represented as -1. And this symmetry is noticed as we move equal distance to the right and to the left. And in conclusion, we can represent our sine to be equal when you have the following, where our sine of our negative angle is indeed going to be equal to negative sine of the same angle. And this is actually shown right here. In order for we to make this particular value, which is pi sine pi over 2, to become negative, all we have to do is multiply r1 by negative sine in order for our sine of negative angle, which is pi, negative pi over 2 to be equal to negative 1. Therefore, an example of this is, for example, sine of negative pi over 2 is going to be equal to negative of our sine pi over 2. And what we have as a result of this is the following. We have our sine negative pi over 2 to be equal to negative 1, and this is equal to, remember, we have negative in the bracket, sine of pi over 2 is equal to 1. Therefore, this negative sign multiplied by r1 gives us what? Negative 1. Therefore, this shows us that indeed there is a symmetry where what? Symmetry at this particular region, which is known as the origin, for it to be odd and not even. Now let's look at how this transformation is going to be equal to this transformation right over here. And so looking at, for our first step, sine negative theta, we know that where theta is equal to 0, our sine is in this case of 0, or in this case negative 0, is equal to 0, which is this point right here. And we're going to start with one specific point, which is where theta is equal to pi over 2, which is at this spot right here. And so where we have theta to be pi over 2, after we label our x-axis to be theta and our sine for our y, we see that yes, our sine negative pi over 2 is equal to what? Negative 1, which is right over here. And so what that results in is that our first point is right here, and we have our sine for our negative theta, in this case pi over 2, to be equal to negative 1. And this is our first point that we've officially assigned, and we're going to look at for the other part where negative pi over 2 is going to be introduced for our pi in this particular expression. That means what? It means that we are going to be looking at here where theta is equal to negative pi over 2, our sine of negative pi over 2 turns these particular two negative signs to be positive, and that gives us our sine pi over 2, which is equal to 1, which is right over here. So therefore, this implies that we have a particular flip in our specific axis as we predict our pattern to be shown right over here, where we are going to have this particular reflection, and this results in our curve to represent our sine for negative theta. Now let's see how this here may or may not be equal to the other one, which is negative sine pi over 2. And when we do the same thing that we did previously by analyzing for this part here, negative sine theta, where our y is equal to sine and our x is theta, we recognize that, hey, for the first point, which we know that where theta is equal to 0, our sine is equal to 0, we are going to put our first point by locating what the sine of our pi over 2 is. In this case, we're looking at negative sine of pi over 2. And so where our theta is equal to pi over 2, our negative sine of pi over 2 is equal to what? We have sine pi over 2 to be equal to 1, and we have a negative sign which is going to be put right there, and this tells us that indeed theta for pi over 2 reflects our negative sine pi over 2 to be equal to negative 1, which is right over here on the y-axis. And this is going to be checked for the other part, which is for negative pi over 2. And what is the sign of that? It means that we have our theta to be equal to negative pi over 2, and this here for our negative sign of our negative pi over 2 implies that our sine of negative pi over 2 is equal to negative 1, and we are going to multiply negative 1 by negative sign, and that is equal to positive 1. And therefore, indeed, when we plot our graph, we see that the first expression is rightly the same in terms of the graph as that of the right expression, which means that in conclusion, we are able to indeed prove that this is an odd symmetry as it's shown right here and stated right here, where we have our sine negative theta to be equal to negative sine theta, which is proven right over here. On our next video, we're going to be looking at our tan and see how that is reflected on the odd symmetry, while on the other video we'll be looking at cosine and how it is proven to be even symmetry. See you on the next one. Stay smart as always and believe in yourselves.